Good morning, children. Today we are going to start with Chapter 5 Light Energy. Okay, Chapter 5 Light Energy. In this, there are two things. One is called refraction of light, and the other one is reflection. Now, we are not going to do refraction. Okay, these things we are not going to do. I want you to directly go to page number 86. Okay, go to page number 86, spherical mirrors. So this all you can strike it. You're not going to have this in the syllabus. Okay, so light energy, you can directly go to this page, spherical mirrors. Now I just want to give a little bit introduction about this. You know what is a mirror, right? Mirror. So every day you stand in front of your plane mirror, and then you're able to see your face image on that, right? So that is called a plane mirror because it is straight. Okay, that's a plane mirror because it is just straight like this. Usually a mirror is represented like this, a straight line. One end they will do like this. It means this is one end will be painted and the other end will be reflecting. Okay, so usually a mirror, they'll just one end they will do like this. That means this end is painted and this end will be reflecting. So if you keep an object in front of this, you get an image of this. Okay, now this is a plane mirror, but in this class we are going to study about spherical mirrors. Spherical means curved mirrors. Spherical mirrors means curved mirrors. Okay, so that is all about this. That is the specific introduction about this chapter. Now you can, okay, I hope you understood it. It has been explained very clearly about how a convex and concave mirror works and where do we use in our day-to-day life, right? So it's a very good introduction we saw. Now let's open the book and let's start underlining. Okay, the first thing is definition of spherical mirror. What is a spherical mirror, or define spherical mirror? A spherical mirror is a part of a hollow sphere of a glass and it has polished surface on one of its faces. So in that video also you saw so he took a sphere and then sliced off a part. Okay, and then that will behave like a spherical mirror. So one side of it will be painted, either the outside or the inside. If the outside is painted, it will be a concave mirror. If the inside is painted, it will behave like a convex mirror. So that is the definition of a spherical mirror. Then if they ask you define concave mirror, or what is a concave mirror? If the outer surface of the mirror is polished and inner surface behaves as reflecting surface. Outer surface is polished, inner surface behaves like a reflecting surface, then it is called concave mirror. And convex, if the inner surface is polished and the outer surface is reflecting. Now outer surface is reflecting means wherever the reflecting face is there, in front of that you have to stand. Now if I stand in front of this side, I'll see an image. If I stand, now for example, this is a spherical mirror, this is a concave mirror. For concave mirror, the object should be always this side. In front of the polished side only you have to keep the object. Always remember that. If you keep an object here in front of this painted surface, it is not going to, a polished surface, it's not going to reflect because it's only this surface that will reflect. So object has to be always kept in front of that. In case of a convex mirror, because this side is polished and only this side is going to reflect, so object should be kept here. Object should always be kept in front of this reflecting surface. If you keep an object here, it is not going to produce the image of it because this side is polished surface. It will not be able to reflect this light. Hope you're clear with this, children. So now so these definitions are also yours seen. This is very important. Terms related to spherical mirror. First is pole. What is a pole? It is the geometric center of the spherical mirror is called the pole. So center of curvature, the center of the sphere. So this mirror is a part of a sphere, and that center of that sphere is called center of curvature. Radius of curvature, the radius of this sphere of which the mirror is a part is called radius of curvature. Principal axis is the line okay, an imaginary line. If you join principal, if you join pole and center of curvature, this line is called the principal axis. Then you have aperture. Okay, the aperture is this, the length of this, the length of the perimeter of the spherical surface means this length. This total length is called the aperture. Okay, so then we have principal focus. Now principal focus is different for concave and convex mirror. Now that is because of the shape of the mirror. Okay, now the basic thing that you have to remember is, in case of a concave mirror, if the rays are going to fall on it, then the reflected rays. Now always in reflection there will be one thing called incident ray and the other one called reflected ray. A ray will come like this, hit the mirror, and then it will be reflected back. Now it can go like this, it can go like this, it can go like this, anyway. Okay, in this case, in case of concave mirror, it will go like this and this ray will go like this. Okay, so this is called converging mirror because this reflected rays can meet at a point. Because of the shape, they will be reflected in such a way that all the reflected rays will meet at a point. This is called converging mirror. Converging means they all come to a point. On the other hand, if you see a convex mirror, because of the shape, these are the incident rays. So this is one incident ray. In this case, you got a reflected ray like this. Now, if it was a convex mirror, your reflected ray will go like this. This is the incident ray and this is the reflected ray. That's because of this shape. Okay. Same way, for this, the reflected ray might go somewhere like this. For this, it came down. So this, it goes out. Now, what is the conclusion? These two are the reflected rays. Now, how the rays are going? They are diverging. So, in case of convex mirror, you get diverging rays. Means rays are going away from each other. Do you think the diverging rays will ever meet? No. As they keep drawing, the space between them keep increasing and they go away from the mirror. Okay, converging rays, they will converge or they will meet at a point, whereas diverging rays, they're going to go away from each other. Okay, but one thing is possible. If I extend these rays back, means I keep my scale here, put a dotted line behind this, put a dotted line behind this, these will meet at a point and that will be the principal focus. That will be the principal focus. Okay, here the rays will actually meet at a point, that is the principal focus. The reflected rays will meet at a point, that is the principal focus. Whereas for convex mirror, reflected rays are never going to meet because they are going divergent. But one thing is possible. If I extend it back, if I put a dotted line behind, they will meet at a point. That is called the principal focus of a convex mirror. Yeah, children. So hope you understood this. This is very important to remember. These two diagrams are very important. You should be able to draw them by yourself. To define principal focus, you need to draw these two diagrams. Okay. Now I will tell you how to draw. You can follow it carefully. Now I'm using rule sheet because you'll all also be doing in a rule sheet. Okay, so for a concave mirror, now you have to draw a mirror like this. So I always prefer, you can choose 5 lines. See, 1 2 3 4 5. So start from here and end here and put it slightly curved. Got it? and then you shade this part. If it is concave, you have to shade this part. If it is convex, you have to shade the other part. Is it clear, children? So this is how you have to draw a mirror. Okay. So from here, choose 5 lines and then draw a curved line and then do this. Okay. Now, the center of this is called pole. Now, because we have chosen 5 lines, the third line will be the center and you can take P here. Okay. Now, what you do? With a scale, you draw a straight line. This is the principal axis. This line is called principal axis. Okay. Now, on the principal axis, what you're going to do is you're going to mark C. Okay. Take 4 centimeter from P and mark C. What is C? Center of curvature. Okay. If I finish this sphere, the center of that is called center of curvature. And then at 2 centimeter, exactly in between C and P, you will have the principal focus, that is F. Is it clear, children? So this is pole, this is principal focus, and this is center of curvature. 2 centimeter here and 2 centimeter here. Okay. Now we have to show the principal focus for a concave mirror. So what you do, take 2 incident rays. One here and the other one here. Okay, this and this. These are your incident rays. Now, why I am putting an arrow mark? That means they are rays. Rays means light rays coming. Now, this I am not putting an arrow mark because this is just a reference line. This is just a line. Whereas these are rays. Okay, so I have to put an arrow mark. Now, in case of concave mirror, just now I explained the rays after reflection. Okay, so what you have to do, this ray, you have to keep your scale like this and then makes this ray go like this. This is how the reflected ray for this ray goes like this. Now, what about this ray? Same way, you keep your scale, join this point and then you extend it. Now, this is the reflected ray for this ray. This is the incident ray, this is the reflected ray. This is the second incident ray and this is the second reflected ray. Now, both of them meet at a point and that point is called principal focus. That point is called principal focus. Is it clear, children? So, now how do you draw for a convex mirror? So, for a convex mirror, same way, you choose 5 lines, but you draw a mirror like this. Okay, like this. And then you polish this side. Is it clear? So again, you can choose 5 lines and then this will be your pole. The center of this will be your pole. Now, you can draw your principal axis. Actually, the principal axis will be here because for a convex mirror, center of curvature will be on the right side. Why? If I finish this sphere, okay, if I complete the sphere, I'll get this side. So the center should be somewhere here. So mark 4 centimeter here and that is the center of curvature. C. And then in between them is at 2 centimeter, mark F, principal focus. Is it clear, children? After doing this, we are going to draw the incident rays. We are going to take 2 incident rays. Incident ray, this is the first incident ray. This is the first incident ray and this is the second incident ray. Now, how will these rays be reflected? Okay, one will go like this one will go like this. But when you extend them backward, they should meet at F. Okay, so what you do, okay, to get it correctly, I'll teach you a shortcut. So you keep your scale between this point and the focus point. Put a dotted line here and a proper line here. Same way, between this point, the point where this ray is touching the mirror, between this point and focus, you put a pointed ray and then extend it. So this is the incident ray and this is the reflected ray for this, and this is the reflected ray for this. That they both are not going to meet here, but when you extend it back, they will meet exactly at focus. They will meet exactly at focus. So this is how convex mirrors diagram should be. Okay, so these are the two diagrams I explained you now. Now, in this case, you don't have to do the shading and all, children. You just draw like this and just put slanting lines. That's enough. For this, like this and like this. Okay. Hope you have understood it clearly. Now this talks about, now there is one more thing called focal length. Okay. Distance between pole and this length is called focal length. Distance between pole and principal focus is called focal length. Now in this case it is 2 centimeter. This length is 2 centimeter. That means focal length is 2 centimeter. That's another definition there. Now, another thing, relation between focal length and radius of curvature. As I told you already, F will be exactly in between C and P. That means this is the radius of curvature, right? The sphere's radius. So that is called radius of curvature. Now this radius of curvature will be 2 into F. Means if this is 2 centimeter, this will be at 4 centimeter. So this is the relationship. For a spherical mirror, the radius of curvature is equal to twice its focal length. This conclusion also you should know. I hope you're clear with all this, children. If you don't understand, please listen to it 2 times or 3 times, then you will understand. Especially, while drawing these diagrams, it will be better if you can pause it and draw it along with me. That will give you a better idea. Okay. Now the homework for today will be, turn to page 96. You have to answer question number 1, 2 and 3. Question number 1, 2 and 3. In the third one, what is focus point? Okay, focus point means principal focus of a concave and convex mirror. I want you to add this. Concave is given. You write and convex mirror. Draw neat diagrams to show its position. Hope you understood. What is the focus point or principal focus, anything, of a concave and a convex mirror? Draw neat diagrams, plural S, to show its position. Okay, so you have to write the answers for these 3 questions. So these 2 are simple, direct. Now what is the focus point of convex and concave mirror? Now as I told you, the principal focus definition. So this is the point where you see the definition of principal focus. The point on the principal axis where a beam of light traveling parallel to principal axis after reflection actually meet. So if they ask you the principal focus of concave mirror, you will write actually meet. Okay. If they ask you convex mirror, they appear to meet. What is the difference? In this, they actually meet, and in convex mirror, they appear to meet. Mean they look as if they're coming from here, but they're not actually coming here. That is the difference. Okay, actually meet for concave, appear to meet for convex. That is the principal focus. So, and draw neat diagrams. So these 2 diagrams you should draw. This is the definition. Both for concave and convex is there in this itself. So you write one only once, that's fine. But 2 diagrams you have to draw. When you draw these diagrams, be very careful. Follow the instructions which I have given while I'm explaining in the video. So please pay attention to that. Distance and everything should be the same as what I told you in the diagram. Thank you, children.